Hey everybody. I wanted to uh, discuss about a very interesting concept that I have been reading and deliberating on for the last few days. The topic is harness engineering. Now, before I come to the fundamental premise and the ideas that underpin harness engineering, it's worth looking back at the last 2 to 3 years and really understand where we are in this hyper accelerated uh, artificial intelligence driven world. So if you remember in 2000 and late 2022, that's when the first version of ChatGPT came out. And over the subsequent year, large language models became a ubiquitous part of the technology milieu. And back then, we saw a range of different skill sets taking prominence in the job market, one of them being prompt engineering. Prompt engineering essentially was the best way to define prompt engineering is uh, the skill of an individual to provide the right instruction to a language model to get the best response. And so fundamentally, these large language models are autoregressive language generating models. They are fundamentally the fundamental working methodology of these models is next token prediction. And so prompt engineering was basically a way to get the best response from these language models. As the as the diversity of use cases for which these large language models started getting leveraged as they became more diversified. We saw these language models being adopted in a wide array of use cases. And at a certain point in 2025, when the utility of these language models in coding became more and more important, and coding agents like Claude Code and later Codex uh, started seeing more adoptions, we steered away from prompt engineering and a new skill set uh, started seeing a lot more prominence. This skill set is context engineering. So, what context engineering essentially is, it fundamentally uh, it fundamentally fills in a vacuum that is left by prompt engineering. So, uh, to give an example, the way language models work is when you give a prompt to these language models, they look at tokens which fall in its proximity and they choose the best possible token to continue the sentence. And so that is the reason why sometimes when you give the language model a very generic prompt, so for example, if you ask the language model to recommend you uh, 5 books on psychology, it will generalize to the mean and it will give you the 5 recommendations which are the most common psychology book recommendations. And so when you're working with language models, you need to feed the language model with the right context so that it would give you the response that is very specific and idiosyncratic to you that you needed for your context. So, for example, if I want to read a psychology book that explains to me the difference between system one thinking and system two thinking, and I give that context to the language model, then it is more likely that the language model will return me Daniel Kahneman's book about System 1 and System 2 thinking, which is the title of the book is Thinking Fast and Slow, rather than recommending me The Psychology of Money, which is a more common book recommendation than Daniel Kahneman's uh, book Thinking Fast and Slow. So that was the premise of context engineering. Now, as we move from context engineering to harness engineering, now remember, Harness engineering is another more broad term, but when when people use harness engineering, they essentially use it in context uh, where they are referring to a coding agent like Claude Code or Codex. And so, what essentially harness engineering is basically defining a layer around a large language model that will help the language model to steer in the right direction to accomplish the objectives that a developer would provide to the language model. Now, essentially, what does that additional layer entail? Now, the additional layer essentially entails the input and output processing or the input and output processing paradigms, prompt management and cache. It involves memory management. It involves tool orchestration and rules for tool calling, and it involves guardrails. So essentially, you can think about a harness uh, as Sebastian Rashka describes it in his article, it's an encasing around the language model that helps the language model to steer in the right direction to accomplish the objectives that the developer wants the language model to accomplish because the coding agents are so deft at generating enormous lines of code, we need to have the right set of rules and regulations in place so that these agents are steered in the right direction and they can accomplish the objectives of the developer. And so going back to the Sebastian Rashka article on Substack, where he wrote a very fascinating article. So Sebastian Rashka has a book series. Essentially, he wrote a book about how to build a large language model from scratch. He's coming out with a book that elucidates how to build a reasoning model from scratch. Now, this specific article was about how to build a coding agent from scratch, where he has given the GitHub link to his mini coding agent. But essentially, he's also describing the idea of a harness, in this case, very specific to a coding agent. But essentially, if you look at the different components of a coding agent here, he's basically describing the live repo context, the prompt cache, the tools, delegation via subagents, the context management. So all of these form the encasing around the language model that will help the language model get the right context so that it can steer in the appropriate direction to get the task done. Different perspective provided by Martin Fowler in his blog, where he has basically posited the idea of an agent harness from the perspective of a software engineer. And so his perspective is uh, look at a harness from like two different perspectives, a feed forward and a feedback mechanism. So a feed forward mechanism is something that the developer needs to build to make sure that the agent gets to the right solution as quickly as possible without dilly-dallying in myriad of different directions and going through a whole host of different issues. And a robust feedback mechanism is basically if an agent encounters a certain issue while trying to accomplish an objective, there has to be a robust fallback mechanism in place that would push the agent in the right direction as soon as it encounters these issues. So that's how Fowler describes it from a software engineering perspective. He takes a feed forward approach and a feedback approach to an agent harness. Um, so to go back to uh, you know the idea of a harness, so just to sort of double click on how we sort of distinguish between you know the the different stages that we have gone through over the last few years. So we started with a large language model, which is a next token predictor. Then we got to the reasoning model. The reasoning model basically spends a lot more time in the intermediate step between input and output. Then we have an agent which is much more capable than a mere language model because it's able to get things done. using tools and state updates. And then we have an agent harness that's an encasing layer around the model that helps to steer the model in the right direction. So that is essentially the idea behind an agent harness. There are some very interesting blogs that you can read that elucidate this idea really well. Now, I was actually trying to incorporate this idea of an agent harness, but I wanted to incorporate it in a different way. Uh, I wanted to introduce a mini harness for myself in my ideas distillation engine. So this is my ideas distillation engine. On the face of it, this seems like a notes-taking app where I take notes from the different books that I'm reading. But as I'm learning new things, I'm trying to add more features to this ideas distillation engine. And so one of the things that I tried to do when I encountered and I was reading on, agent harness is I tried to create a sort of a mini writing harness for myself where I can distill ideas from different books and through a writing harness or a writing assistant harness, I can, uh, you know, create an essay uh, with some of the insights that I took from a specific book while leveraging a robust model. So essentially, to provide you a little more insight as to what is the underlying architecture. So the most important part of this writing harness is the working memory. So the working memory has a bunch of different components. Essentially, the idea that I started with is I want to be able to not only summarize a specific book that I'm reading, but if there are contrasting ideas from like two different books, then I should be able to synthesize those ideas and compare and contrast between them with ease. So, which is why it has like a bunch of these, different utilities from tensions to intersections, argument maps, outlines. So memory management is actually a very it can be considered as a different topic in and of itself because managing the memory so that you don't overload the language model and create a context blot because a context blot will essentially lead to poor performance. That in and of itself is an art that needs to be mastered. And actually, I'm planning on reading more about, memory management myself and actually incorporating some of the best practices to, you know, uh, to harness engineering. So I'll actually improve on this a little bit more and talk about memory management specifically in probably an upcoming video. But this is how, at this point of time, my working memory paradigm looks like. And the broader architecture has four different components. It has a planner, it has a tool execution layer, it has a synthesis layer, and it has a draft layer. So this is how sort of the current architecture looks like. So a user message leads to a system load that takes the information from the transcript and from the memory. It plans on, what it needs to write about. Then there are a bunch of tools that it can leverage. All of them are actually part of the ideas distillation engine. Then it goes to the synthesis layer where it synthesizes the different ideas, mixes and matches maps to different concepts. Then finally the draft layer, this particular draft layer, it basically drafts out the final paragraph. So this is the harness of the encasing layer that I have over on top of my language model that I'm using to basically distill ideas. So let's go back here. So at this point of time, I just began to, sort of revise and revisit some of the interesting ideas that I read in John Osterholtz's wonderful book, The Fundamentals of Fundamentals of Software Design. Uh, sorry, a philosophy of software design. What am I saying? Uh, so let's actually demonstrate something to you. So up until this point, this is what I've written. In the world of software development, complexity is not just an inconvenience. It is a central obstacle that determines whether systems remain robust or devolve into brittle, unmanageable code bases. John Osterhout argues in philosophy of software design, the proliferation of complexity is often subtle, emerging, and decision leads across modular boundaries, yada, yada, yada. So let's just add one more paragraph talking explicitly about the best practices to write software modules. And let's just say I write great job. Now, continue this paragraph by mentioning the importance of information hiding while designing modules. Okay, let's. So once I send that, the model is going to it's going to think for a bit, and as soon as it comes up with a definite paragraph to write, it will give me an option whether I accept it or I reject it, or if I want to make some changes, I can ask the harness to give me some changes. So, all right. So this is what it gives. So this is the proposed change. When designing classes and modules, developers should prioritize hiding internal details, minimizing the information that must be exposed across boundaries, and structuring interfaces to make common sense. Central to this approach is the principle of hiding emission leakage when the system by rigorously protecting. Okay, so this looks good. This is how it is tracing these ideas back from the notes in the book, and the memory mechanism that was put in place is allowing it to sort of mix and match between ideas, think about where the tensions are, and essentially think about also where the ideas that intersect the instruction is intersecting with the ideas in the notes. So we approve this, and so this is how I'm currently uh, this is how the harness architecture is currently built. Now this is not a final version of it, but it's an interesting art that I am in the process of learning myself and getting better at. So hopefully in the next video, when I talk a little more about memory management and the nitty-gritties of that, I can improve this a little bit more. But do mention what do you think about this, and if you have any feedback, any further ideas, do let me know. And thank you so much.